Hello everyone. What we're going to be looking at is we're going to be looking at something known as acid-base disorders, right? Acid-base disorders. So with acid-base disorders, we're going to be considering three main values. Okay, three main values. The first value that we're going to look at is our pH. Okay, our value for our pH. pH stands for the potential of hydrogen, right? Potential of hydrogen. So that's where we get the P and the H from. Our range for pH is going to be 0 to 14, right? 0 to 14. As we increase our pH, so meaning as we increase the number, we move up, that is becoming more basic, and as we decrease it, that is becoming more acidic, right? Moving toward acidosis. So in the context of our acid-base disorder, what we're going to be looking at is we're going to be looking at the pH of our blood, right? So we're going to be looking at the pH for our blood plasma, and our normal blood pH is going to be 7.35 to 7.45. Right? So as long as we can stay within that normal range, 7.35 to 7.45, then we're considered in homeostasis for blood pH. Right? The second value that we need to consider is our PaCO2. Right? And this is going to be a value of 35 to 45 millimeters of mercury. So this is saying the amount of CO2 in our arterial blood, right? In our arterial blood. For our discussion of acid-base disorder, as you increase the amount of CO2, that is causing the blood to become more acidic. So an increase in CO2 is causing a subsequent decrease in blood pH. So we'll erase that. And then our third value that we're going to look at is going to be our bicarbonate, right? Bicarbonate, HCO3. So for this value, this is going to be 22 to 26 milliequivalents per deciliter, right? 22 to 26 milliequivalents per deciliter. I'm sorry, per liter, not deciliter. So just say per liter. For bicarbonate, as we increase the amount of bicarbonate, so move closer to 26 and above it, that is also causing an increase in pH. So it's causing the blood to become more basic, more alkaline. Okay. So with these values in mind, what we can do is we can look at acid-base disorders. Right? We can look at acid-base disorders. So essentially, we can look at a particular set of ranges for all three of these values and describe what the disorder is going to be. Right? Now, one thing I should actually mention before we do this is or are the two types of disorders. Right? So these disorders are going to be what are called respiratory. So we'll do respiratory disorders or metabolic disorders. Right? If it is a respiratory disorder, it's going to involve an abnormal CO2. If it is a metabolic disorder, it is going to involve an abnormal bicarbonate. Okay? So keep those two things in mind as we look at some of our disorders. Right? So what we'll do is we'll write out a set here. So we'll do a pH. We'll say a pH of 7.3. We'll do a PaCO2 of, let's say, 51, and we'll do a bicarbonate level of, let's say, 24. So we'll do milliequivalents per liter, and this will be millimeters of mercury. Right? So first things first, whenever you look at these values, what I recommend is you look at the pH first and determine what the disorder is in terms of acidity versus alkaline. So meaning, are we too acidic or are we too basic, right? So we said the normal blood pH is 7.35 to 7.45, right? Well, you notice here we're at 7.3, so we're a little low. So remember, low, was that acidic or was that basic or alkaline? Well, a pH that was too low is going to be acidic, right? So we know automatically, we can write down here, this is going to be an acidosis, right? Or this is going to be an acidosis disorder because we're already in that acidotic range. We're below 7.3. Right? So next thing to do is go in and we'll look at our two other variables. So we'll look at our CO2 and we'll look at our bicarbonate. So for our CO2, we know we're at 51, right? So remember, a normal PaCO2 we said was somewhere around 35 to 45 millimeters of mercury. Well, we're too high here, right? We're at 51. And I said earlier that if you have more CO2, that's like having a lower pH, right? Well, those two things fit together perfectly, right? We have a high CO2, and that is corresponding with our low pH, right? So, right there, we know that this is going to be a respiratory acidosis. Right? This is a respiratory acidosis. And just for fun, we can come down here and we can look at our bicarbonate, right? We know normal bicarbonate is 22 to 26 milliequivalents per liter, and that's a normal range of bicarbonate, right? So we know that this is a respiratory acidosis, right? Let's scroll down and we'll do one more. Let me get rid of this. This was from a previous lecture. Let me get rid of this for us. So the next one that we'll look at is, let's say here we have let's do a pH of 7.51. We'll do a PaCO2 of, let's say, 41. We'll do bicarbonate of 32. Right? So again, first things first, let's go in and let's look at our pH. So we know we're at 7.51. So is that too basic or is it too acidic? Right? Well, we're too high. We're above our normal 7.35 to 7.45. So we know automatically we're going to start off, this is going to be an alkalosis disorder. Right? Second thing, let's go in and let's look at our CO2. Right? So we know our CO2 here is 41. Right? And again, the units here for CO2, this would be 41 millimeters of mercury. Right? So we want to add millimeters of mercury, and for bicarbonate, right? But we're at 41. Right? So remember, our normal is 35 to 45 millimeters of mercury. So we're right in that normal range. So everything's good. Right? And then lastly, if we go down and we look at our bicarbonate, we know our normal bicarbonate is 22 to 26 milliequivalents per liter. And so here, we're a little too high, right? And again, if you have more bicarbonate is also contributing to this increased pH, or this more alkaline state, or this more basic state. And again, since it's CO2, this is going to be a metabolic disorder. Right? So we can write down here metabolic alkalosis. Right? So again, just like we did for this one, that was respiratory acidosis, we are going through looking at the pH, we're going through looking at the PaCO2, and we're looking at the bicarbonate, and we're looking at seeing what is wrong potentially with each range or with each value, and then tying that back to our. Now, you can have other instances that we won't cover in this video, but we'll cover these in a separate one, in which you can begin to have something called compensation, right, where you're starting to have a compensatory change in either maybe CO2 or bicarbonate to accommodate for an abnormal range of levels. Right? So you can have partial compensation, you can have total or full compensation, but these are topics that we will address in a separate